Here's our first example of evaluating a definite integral. We've been asked to evaluate the definite integral from -2 to 2 of the square root of 4 minus x squared dx. That means find the area under the curve radical 4 minus x squared between -2 and 2. So notice that on your paper, your handout, the dx was inside the radical. That was a typo. I'm very sorry. The dx is on the outside because every integral should look like a height times a width, because what we're really doing in an integral is adding up infinitely many rectangles. Cool. So we can get around it in this case because we happen to know that the square root of 4 minus x squared describes a semicircle. It's the half of a circle with center 0, 0, radius 2, whose just the top half. Okay, so how do I find this area? I'll color it in for you. Is this area I care about? I can use what I know from geometry. That area is 1/2, because it's only half of a circle. That look like a half. Pi times r is 2 squared. So 1/2 pi r squared, which makes half of 4 pi, which makes 2 pi. Okay, so important idea, you might have already thought of it. If any part of the curve we're trying to find the area under is negative, then we have to pretend that that area is negative. And technically area is never negative. But if that area falls below the x-axis, we consider the area negative and we subtract it out. So here's another example of a definite integral. We've been asked to find the area under the curve f of x between -1 and 4. The good news is that this shape, the shapes of those areas that I just colored in, they're areas I can figure out using geometry. I can either add up a bunch of triangles and a rectangle, or I can find the area of a trapezoid, and I can figure out the area. So I don't need to know any other calculus. But whatever I get for the area of the red section is going to have to be subtracted from the area I get for the blue section. So the area of the blue section, for me, that's a trapezoid. Feel free to split it up into triangles or rectangles, but I'm going to think of that as a trapezoid. And this is a trapezoid how you were used to seeing them in geometry, so I'm going to take the average of the bases. 1/2. Across the top, that's 1 space wide, plus across the bottom, that's 1, 2, 3 spaces wide. And then how high is that trapezoid? It's got a height of 2. And then I'm going to subtract away, and that's another trapezoid down there. So that trapezoid has, I need to take the average of the bases. The bases are 2 and 1. And the height of that trapezoid is 1. So I get that area of the blue trapezoid is 1/2 times 4 times 2. That makes 4. The area of the red trapezoid, 1/2 times 3. So 3/2. And I'm going to subtract because the blue area is positive and the red area is negative. So 4 minus 3/2. The correct label for your answer would be the integral from -1 to 4 of f of x dx equals 4 minus 3/2 is 2 1/2 or 5/2.